Quite frankly, I'm emotion elliptical. A scientist should be honest. If you're experiencing a human moment, women go through this. Am I bleeding again? Well, a scientist goes through the same thing. Just because you're male, oh, it's actually worse for a male. Let's start here. What's the dominant feature here? I believe it's C. The diameter introduces a new aspect to the circle. The O with the circumflex over it, in my lingo, in deference to one of the greatest scientists who's ever lived, is a force. That is a force direction. It's a force vector in spherical space, but you're looking at a circle, so you're looking at a projection downward from a higher dimension than what you're seeing. At least I'm honest with my captions. But the R is the most important of the lines. There are two lines. The blue one, which is the diameter, which the Greeks recognized for very good and sound reasons. The diameter of a circle is an extremely important relationship between C, which is what we want, and D. But what we use now, which is far better, is the relationship between C and R. R is the radius. And I want you to see something, and this is basically the reason why I wanted you to look at this at all. R is a variable. If R gets smaller, C gets smaller. Let me ask you a simple question. Which one is larger? Numerically, it's C, because it's about 3.1459 times the diameter. But what about C to R, which is what we're talking about? Well, that's not pi, that's tau. And that's the difference between R and D. Tau was rejuvenated, or there was an attempt like Frankenstein. If you've seen Young Frankenstein, you should watch that again. I think I'll watch it tonight. The center of this circle is labeled with a green O. Does that have a number? Yes, it does. Because of D. Because of D, O has a number. And R, the red line, which is the radius, which is half D. So they're directly related. You could use either one. But why are they related this way? It's because of a property of the circle. That if you draw that line the way it's drawn through O, which is actually one way of deriving the position of O, although you'd need two of them, wouldn't you? Orthogonal lines to get O exactly. Not exactly, but quadratically more exactly. That's the basis of modern mathematical science and physics. From O, see, I'm going towards O and away from O. That's that dotted darker blue line. That represents force. And now you can interpret the two O's. Because one, they have to do with the surface, which is C. And relative to C, there are two directions, but only in circular space. All of this applies directly to the sphere. That's already known, but I raised that perception to a stronger power. It's like, yeah, we discovered this. It's about time we recognized what we discovered. The reason I wanted you to see this next is because the radius and the diameter are related. And it's the radius we use now, but we still use pi. It's very interesting to try to consider the reason why we might still use pi when the relationship between that red R, which is a line, it's a line segment from the origin to the surface. That defines C. So we need to know that relationship directly. We currently interpret it in terms of a number called pi. Approximately 3.1 is approximate because it's irrational, and this is what stymied the Greeks. It's irrational. Well, you simply need to change that. The C cannot be irrational. This is the number system we want. Is based on C, not on R. But in order to convert, you need to know the relationship between C and R, because you cannot remove the irrationality. What you can do is convert between two systems, one of which is innately irrational. That's the one science uses, called linear geometry. But when you unitize C, all the problems go away. And that's the basis of a new number system, where C is 1. The profundity of that is extreme, and I wish to convey that. But you see, science is based on proofs. And so I want you to see directly the ultimate conundrum is between irrational numbers and rational numbers. Because rational numbers have been known since antiquity to be the correct numbers. The Greeks thought so. They were right. What are rational numbers? I discovered the correct definition of rationality in every level, in every sense. Rationality is the key to numbers, but your linear number system has very limited usefulness when you're trying to compute from a universal frame of reference, which Einstein missed out on. And the ones going to the center, like Paul Dirac, Schrödinger, and others, Feynman, trying to get to the center of things rather than the edge, they encounter the reciprocal problem of going to the edge. Because if the universe has neither center nor edge, which is what Euclidean mathematics declares, then you need a new number system, you need a new logic system, you need a new approach to how you see reality. But it has to be numeric. We know this because numbers can be computed, and we know that's advantageous. That is the legacy of technology. Technology proves that using the correct geometry will get you everywhere, even if you have to fudge it with mathematics, and that's due to the calculus. It gives us earthly solutions. So you have to wonder who rules the earth, but I leave that up to you. But that dotted blue line right there, that points obliquely approximately southeast from the origin, you'll see is labeled with two O's, one with a circumflex and one which has got a inverse hat, which I believe is called a diaresis, but I could be mistaking that for another glyph. Those two O's represent two directions in universal space, according to a dual force system invented by a Jesuit priest 250 years ago, which defines relativity correctly at a lower level, whereby Einstein's relativity appears in its true aspect, justifying Albert Einstein's discoveries and subjugating them to a much higher order system. This is the duty of geometry, to report any findings in this area which could change our perception of reality all the way down to the basis. This geometry based on this dotted line with two heads, and you'll notice that the arrowheads are slightly differently shaped. That's because the surface, called C, is the boundary unifying two domains. And you notice I use the word unifying. C unifies two force realms, and they're depicted in what I labeled this diagram below with, which is the surface, which is C. The exterior represents centrifugal force, a Noether force, and the interior represents the reciprocal force, and that is the correct way to say that. It's also the conjugate force, and it's also the perpendicular force, but it looks polaric on the dotted line. That's because the dotted line where it crosses the surface and goes inside towards O is imaginary. That is imaginary. And that's the Planck length, is from O circumflex to O green. Is O black from O to O green. But if you integrate it, it's O to C. It's green O to black C. That's the surface. The inside of that surface, which you'll see I have labeled exterior and interior. The interior is imaginary. The exterior is space. The exterior is space. You're looking at the quantum, and the Planck length is from circumflex O to green O. It's the radius. The radius, the integral radius, is a pressure. And there are two pressures called two forces. But what is stymied every single mind is the two forces are conjugal, such that space is orthogonal with anti-space, sometimes called contraspace. It's the realm of C. That C has been proved to be one. It's unity. It's the number one, the interior of which is imaginary. That explains a lot. You will tune in, or you will never understand the quantum, because that's what you're looking at. And you're looking at three quantums. It's not quanta. It's three quantums. The red R, the black C, and the C that represents the sphere of this eigen. This is the eigen of angular momentum. Laurie Gardy, God bless you. You gave this to me. I could not have done this without Laurie Gardy. But you're looking at three quantums. And Ruger Josef Bošković has the force curve to describe red R with green 0. I discovered the mathematics and geometry that justifies that to a transcendental level of insight that can be proved. That's my LaTeX archive document. But I just discovered I can use GitHub for a static web page. I will publish to GitHub using Git and CLI, and I will clone. I just learned all this stuff in a week, so I'm pretty excited. I'm going to publish now, and I'm going to publish where you can read my papers. There will be more than one, but the first one will have every one of my discoveries in footnotes so that you can see the list, and you will be impressed, or you will fight me in debate. Kurt Chai-Mongol. You want to get... and I will charge money for this. I've decided. You'll never take me seriously until I make you line up to see me. You will. And this is Anagalactic giving you the secrets of the universe. I will explain this. I swear to God. Although maybe not in the next lecture. This is pretty spontaneous. I hope you appreciate the effort that I put out for you. This is for you. So that whatever your question is to the universe, At least you can approach the universe rationally. But until you understand space-time, it's a good thing you're tuned into Anagalactic. Keep looking up. We'll be right back. We have a spatial perceptual system. I think Euclid pretty much proved that. But it's more than just spatial. You can be more specific. We have a flat screen perception of reality. What you see is flat. I can prove that. Look at the full moon. If you add up all our paradoxes, they all come down to the same thing. And if you had to give it a name, what this same thing is that all our paradoxes come down to, it's imaginary space. What does that mean, imaginary? Well, it means we can't see it. But this can get really profound, and in this case it's extremely profound. Because it's the difference between spatiality, which has to do with position, that's the opposite of momentum. So there might be a space particle, there is. It just so happens there is a space particle, so we have an identity there. But you would want a corresponder, really a conjugator. And it turns out this is accurate according to everything we already know, but also according to what we might be able to perceive if we saw certain phenomena in a different framework. If you look at things linearly, you're going to have to orient yourself that way, which is to a zero center. But if you compute the universe, it turns out that by doing so, what you find out is that the universe is telling you that there is another number system. It's spherical. And what's remarkable, and perhaps the greatest miracle of all, is this spherical number system is made of whole linear numbers. And I can say whole because that's the definition of any linear number that's 1 or greater, but it's indexed on 1, which means 1, 2, 3, 4, 5. That's the index of the metric of linear spatial separation, as I taught you. The index is 1 because it's the lowest number after 0. That's the quantum jump on the necessarily quantizable line. Why would I say it's necessarily quantizable? It's because if you take the only other kind of line, which is represented by the circle, as you know, this has to do with force now. When you're talking about circular space, as we are now, we're actually talking about spherical space, of course. And there is a direct relationship between circular and spherical space, which has no correspondent in linear systematic space, which is 0, 1, 2, 3, and 4 dimensions. That's 5 total. If you include 0, there's a 5th. It's beyond the counting numbers. That's an indicant of the peculiarity of 0. 0 is the most strange number, although it's perfectly rational and makes perfect sense physically if you're only considering distance, because then the line is the definition of distance. You start with a center, which is 0. It can be proved that that's the center of the line because of the two balanced infinities of plus minus, which defines the concept of polarity, which is quite significant. So once you have the center of the line, you can take distance, which would be the positive numbers, correct? So it'd be 1, 2, 3, 4. The index is 1 because the metric is quantized as a one-component number. Now in circular space, it's two-componency. You cannot do anything with a circle until you realize it's a completely different kind of line. It's a closed line, which means it's a two-dimensional on a plane. If the line is one-dimensional, you could say that it's one-dimensional in a plane, and in fact that's the basis of trigonometry, is that if you start with 1D, you can extend it to 2D. That would be a flat surface. But when you start with a closed line basis instead of an open line, thinking of the straight line as an open line because it has two infinities, the closed line has no such thing. It has no infinity. But it's compensated, and this is an interesting thing to be able to say. The circle, because it is not doubly open to infinity, as is a straight line, The circle is a closed line with no infinity. It has no correspondent infinity that exists for the line. Then the concept of a circle is obviously much more powerful than the concept of a line. What I was able to prove in 2022 is that a line is a circle. You have to have an embedding space. It can be proved that the closed line is the embedding space for the open line. Because as you open up a line, if you choose to go the Euclidean route, as the line opens, it opens up a circle. And that's never been directly stated at any time. Indirectly it has been, but as an axiomatic basis for beginning a geometry, it's entirely new. Because it means that linear space, since its derivative of the circle, is exactly that. It's the derivative of the circle. In the calculus sense, it can be proved. However, the calculus is a most fascinating function. I've dealt with that in previous lectures. This circle is significant. You'll see in the upper left, it says exterior and interior. C, you could say it means circle, but here it means circumference, which means surface. You can say it's a surface is because it has an interior now, which the straight line obviously does not. Neither does a hyperbola. Neither does a parabola. These curves have been related to this, which is a circle, which is unique. It's not strictly speaking a part of the family of lines, which really end at the parabola, after which the parabola, by definition, if it closes any further, will collapse to, I'll just say, a very tight ellipse. And that's the beginning of the closed line sequence. It's at the end of the family of hyperbole as the ends of the line lift. They finally have to close, but before they close, it turns into a parabola, which is a unique shape in relationship to the family of hyperbole. The parabola stands out. There is, in a sense, a family of parabolae, but it's what happens after whatever, either the hyperbola or the parabola collapses. It really collapses through the parabola because that's a divisor, after which it collapses to an ellipse. Or the reason I hesitate is it might collapse to a straight line, which is essentially the quantum paradox inside out. The diameter is a bright blue, but going from the center southeast, that is showing a force line. That's what that means. That's why it extends through the surface. And you know, the surface is synonymous with the circumference, but it has a different nuance. The circumference is conceived to be a number, which is correct. But the surface is a geometric subspace. That's technically correct. No one would argue with what I just said. It's just, I'm laughing because it's so profound to be able to say it, is that the line, it's always the diameter of a circle, because the circle is the natural embedding space of the line, and that subjugates the line to the circle. So what we really want is not the line, but the reason we have the line, and it's so prominent to dominate science, is because that's where the numbers are. So the trick is to transfer the linear number system, which is computable, to C, which is the surface of a continuous closed line. What that means is it manifests the boundary between force fields. We know that now. The force can be conceived of as a field in one instance, the proton. The proton exudes a force field. This is mightily profound, is that the proton induces a space field. It bends space. And so it is correct to say that space is curved. It has a characteristic, and Einstein actually discovered this. I don't see how you can avoid saying that Einstein discovered this. but he discovered it in such a peculiar way. And I should explain that. I do give the impression, I've noticed from reviewing my videos lately, it sounds like I'm down on Einstein. No, but what is so amazing is that what Einstein penetrated, the realm that he penetrated, is way better than he ever. I believe that he saw what I see, but he was constrained by linear algebra to a linear solution. That's perforce true. What I'm pointing out here will be on mathematics. What is the mathematics that justifies this transfer of the center of anything from 0 to C? Because what I'm saying is C is the quantum, that it's a sphere. The quantum itself is a sphere. It has to be. It's actually true that you need some mathematics in order to interpret that. And the miracle is that we have the mathematics already. There's actually nothing to invent. But it will seem like an invention because that dotted blue line that runs like this, that has the circumflex O, those show two forces, which in relation to the radius is an integral. Because you see the radius is just a red line, but now you know that the line is subordinate to the circle. So this is the meaning of the calculus, only it's kind of invert and it's much simpler ultimately. The relationship between that red line, you'll notice that it ends at the surface, so it's an internal measurement. Whereas the dotted blue line crosses the threshold. The surface, as I taught you just now, the circumference of the circle is a single thing in a differently dimensioned space. And it's rather obvious what it is because of exterior and interior. If you're talking about a sphere, you're talking about a center. That's gravity. Gravity makes a center, which we call, logically enough, the center of gravity. But it is that geometric point O. Call it O for origin. But it's the number 0. That's fine for this. You don't need to give it a number to see what it is. It's the center of a circle. But what does that mean physically? It turns out that that has a physical meaning. It's a force line, but it's not the radius. It's the integral of the radius on the circle. In other words, it's all the r dialed all the way around. You could say if you divided it, if you quantized it, which you can't do, but if you could quantize the circle to 360, it would be 360 degrees. But the curious thing about the closed line is that it can't be quantized, although there's a loophole. There is a quantum jump. It's just that we've measured it in a certain way. And it's really that r. That we've measured the Planck length, which is considered to be half of a wavelength, although that's ambiguous. But you can see from this diagram, with the addition of the dotted blue line, that what that actually is two different lines. And the one pointing in towards O is much, much different than the one pointing out. And that's why they're labeled both with an O, but with this kind of a hat and this kind of a hat. The one going out is meant to open up like a hyperbola. It's interesting what it transforms itself into, which is a most specific kind of hyperbola. And it's a kind of hyperbola. It's an asymptotic curve. And that is a most interesting curve. If you think about what it is, it's hard to distinguish a hyperbola because one goes in and the other goes out. It's not linear. They're reciprocal. And that's a major discovery. There is a number line there. They're reciprocal numbers. So you have to have 2 to make 1. That's called the two-component number. It's the equivalent of complex space, as I'll show you. Currently, what you're looking at with those 2 O's, one pointing in and one pointing out, those represent 2 forces. One is centripetal, that's gravity. The other is centrifugal, that's EMR. So you're starting to see how the unified field theory will come about. You're actually looking at it. It's interesting to begin this way because you can see that a closed line has an interior and an exterior. That's where the 2 numbers are if you project it in a certain way. So that from the surface, you would have to assign a number to it because it's a different kind of number. C is a different kind of number. It's not a linear number, but it should be a number. It should be a rational number. Well, that's the secret, is that C is a rational number. Which one? The only one it could be. It's 1 over 1. That's 1 proportion 1. It's also said to be 1 divided by 1, but that's the least favorable interpretation. 1 proportion 1 is the best, but 1 over 1 is the most convenient. If you consider C to be a boundary between interior and exterior, you can make a mathematical system out of that statement alone. And that's a profound thing to say. But it's a 2-component number system, which has different rules than the linear number system. But what it has to always be is linearizable with no change in meaning. So this new number system is actually linear mathematics extended, but it's extended according to the principle of the calculus, which is profound because it solves a lot of our problems in mathematics with the calculus. Because now we can integrate the calculus itself, such that instead of trying to get 2 numbers off of a curve, which is what Newton did in order to mathematize the orbits of planets around the sun. It's a general solution, though. He did very well. Well, this is the integration of that insight, so that the calculus that Newton invented is no longer needed because we figured out the use of the calculus, is to integrate what we consider to be differential space. That we need differentials in order to get 2 numbers off of the circle. Well, a better solution is to put those 2 numbers onto the circle. And if you make the circle a proportional number, which is a 2-component number, it's 1 over 1, then you have a new number system. But it's actually the oldest number system, as I'll show you, but not right now. It's sufficient to say that the C right there, the letter C, that variable, that's the circumference of the circle. It has a value. It's 1 over 1. If you say that, then you can parameterize the circle on 2 numbers that are on D. D is the line that bisects the circle. You could say it's arbitrary, but once you select it, it's no longer arbitrary. And that's a partial solution to the quantum paradox, as I'll be showing you soon. But D is the line, and that has the linear number system on it. That's very important, because C is not composed directly of linear numbers, but each component of C is a linear number. It's 1 over 1, and we need to prove that both of those are linearizable. We can do so. If C is 1 over 1, then halfway to the center on D, halfway to the center on R actually, would be 1 over 2. Correct? That's a point on R. Because C is 1 and the origin is 0, correct? So the distance to the surface is 0 to 1 on any r. On any r. That's the key. It's not just r. It's r in any orientation. Well, that's the integral of r. That has to be defined, but it actually already has been. This is the inverse of the calculus. It's the antiderivative. So what we can do is, we can take the unit circle where r is 1, and we can invert r and c. Because the relationship between r and c is fixed. It's a constant in the universe. It's a geometric constant. We call it pi because it's measured on d. But when you measure it on r, it's 2 pi. And that's 6.28. It's about 6.2813. But since it's 1 in the third spot, you could say 6.28 and you're very close. It's 2 pi is the circumference when the radius is 1. What we want now is to invert that. And that can be done very easily using the formula which converts between the radius and the circumference, which I think you know. I believe it's 2 pi r. Well, 2 pi is tau. That's 6.28. It's 2 pi. So 2 pi is tau. You can say that. You should get used to that because tau is a much easier number. Because it represents the relationship not between the diameter and the circumference, that's pi, but between the radius and the circumference. That's 2 pi. That should have its own symbol. It must have its own symbol. It's tau. That was invented in the 21st century, believe it or not. Big deal was made about it, but it didn't go anywhere. Well, that's fine. It's just an interesting story to tell in the future around campfires and some other planet, probably. But that dotted blue line is actually not one line. It's 2 lines that represent 2 opposite forces. If it's centripetal, going in, it's gravity. But if it's going out, it's light. It's EMR. Only light goes out, nothing else does. Only gravity goes in, but then you notice they're in 2 domains. They're in 2 different domains. The space is pulled in by the proton, but the electron has nothing to do with space. It's not a spatial particle. It's an energy particle. And it's energy that we cannot see. But it's that which generates the notion of time. It can be proved that time is a derivative of energy. It's called frequency. But then you have to account for wavelength. This circle does. And I'll show that to you. If you extend the diameter beyond C, so that it looks like that dotted blue line going this way, if you imagine it going further, you can use it as a metric to parameterize the circle this way. That the circle is 1 over 1. Well, if you go halfway to the center on D, that's 1 over 2. If you extend that blue line out to 2 over 1, then those 2 numbers represent the surface. Because when you multiply them together, they multiply to 1. If you double 2 to 4, you half the distance to the center. The distance to the center is now 1 over 4. It's gone 3/4 of the way to the center, so it's 1 over 4. But the outer number has jumped another ring. So the outer number is making concentric rings of space. What's the inner number doing? You could say, you might guess, that it has something to do with time. You're right. But there's another hurdle that has to be crossed. Because the interior of C is imaginary. I proved that. You'll have to accept it. But I'll prove it to you retroactively in a moment. The interior is imaginary. That is imaginary space. Because it's the quantum. The interior of C is the quantum. It can be measured, but it will have to be measured on a certain kind of curve. That curve has already been measured by a man who lived 250 years ago, but I don't expect you to believe that. It's just a fact that you'll come to accept. I hope you're having fun. But now you can see, this is called inversive geometry. And so when you extend these two lines, this way, D, that extends, well, you don't extend it the other way, you just extend it out. So D is extended out. That makes space. Because remember, the inside of C is imaginary, but space is real. So what's outside of C is space, but what inside of C is not space. It's something else. It has to be because it's inside. Otherwise, why is C even there? You could say it that way, but that's actually not quite logical. But there is a very definite logic to this construction, because it makes a number that goes in reciprocally with a number that goes out, and those two numbers always multiply to the surface. And that goes to infinity. But it undefines zero. And so zero is no longer a number. You know why? It's because the center of your system is 1. And so Zeno's paradox does apply here. To the proportion that this number is going out, 2, 4, 8, 16, this number is going in 2, 4, 8, 16, but it's under 1 instead of over 1. And so you can see immediately that to the proportion that the number going in the two-component number never attains 0, it does not attain 0 to the same proportion that the number going out never achieves infinity. And so this defines imaginary space in spherical space such that it defines the quantum, and it defines what's outside the universe. I don't know what else to tell you except that is a major discovery, because it's much more than the grand unified theory or the theory of everything or the unified field theory. It goes way beyond that. But that's saying a lot. I hope you enjoyed this. I'm worn out, but I always like to make a video or two each day. Keep looking up. We'll be right back with you. This is Anagalactic, giving you the secrets of the universe. We'll have more on this diagram soon. Don't worry. I'll give it all to you. We'll be right back.